Okay, cool. Okay, example one is super easy. Super easy is you need to find the solution of this inequality. 3x, only one, no system. Minus 2y less than 6. Okay. Okay, entonces now my recommendation always is you isolate the y, que es the dependent variable. Entonces now we have minus 2y less than minus 3x plus 6. Now, in order to isolate the y, you divide it by -2 both sides. Y alone, and remember, when you divide by negative or multiply by negative inequality, the direction of the inequality change, right? This is super important detail. -3 divided by -2 is positive 3 over 2x minus because positive divided by negative -3. Entonces now I want, yeah, this is the inequality expressed in another way, more clear. Now it's important to isolate the y because in the original maybe you don't see clear, see the symbol actually stay less than or greater than. During the process you need to change, this is greater than, okay. Now immediately if you want to do the graph of this, well, you express it like an equation. This is called, related equation, because this equation is a line, and this line is split the plane into semi-plane, and you need to shape the semi-plane que es solution, no? Okay, in this case dependency is greater than or less than in this case. So convention to understand this. You are doing the line in two different ways. Solid line when this greater than or equal. No, sorry. When this solid line is when this when it include equal, is solid line. O sea, in the scenario que es greater than or less than, you put a solid line. When you have greater than or less than, because the line is dotted. This is logical, no? Because the dotted indicate that the solution, when you shape the solution, supposedly we shape the solution. In this case, the boundary, is the line, includes the solution. No? In this case, no. You shape like that, depending, no? Now, you have a line. The line is split into semi-plane. Now, since greater than, it's obvious using the common sense. Okay, you shape above. Because it's greater than, no? Since less than is below. There are another way to visualize. I want to explain every way. But let's do it. No more blah, blah, blah. Suppose I bring the rectangular coordinate system. I need to do this to express the final answer. Now you plot the line. We focus on the line. The y-intercept is -3. I plot that. Ooh, look at that. This point is 0, -3. Because as you compare with the y equal mx plus b, no? And b is -3. That means que -3 is the y-intercept. And the slope is m is 3/2. Therefore, it's positive to say over 3 units over 1, 2, 3, and 2 units to the right, 1, 2. And you obtain the second point is 2,0, no? Ready. You are ready to do the line. Using the rule. Okay, let me try. You connecting both points using the angle, proper angle. Now my challenge is The line que I'm doing is dotted line or solid line. Es obvio que es dotted line. Why? Because they're not equal. So in the original problem, I have no equal sign. Here, no equal sign. No equal sign. Therefore, it's obvious that the line don't belong to the solution. And what part I shape? Well, okay, I suppose using my common sense, okay, the part I shape is above the line because it's greater than, and that's simple, no? And so you shape like that. This semi-plane. Everything is solution. This is one possibility. Sometimes confusing because not always the inequality represent oblique line, maybe a horizontal or vertical line or curvy, like you see in another example. But the solution is like that. So the red part I highlight is the solution. One possibility is you take a testing point. A testing point, universally, everyone takes 0,0 because it's too easy to understand. And you evaluate in the regional inequality or in the new one, it doesn't matter because they are equivalent, no? In the rectangular or in the circle, you take, for example, in the original is 3 times 0 minus 2 times 0 should be less than 6. So this is 0 minus 0 is 0, is 0 less than 6 is completely true statement. That means that the point 0,0 belongs to the solution. Either way, guys, using the idea for above is greater than, below is less than, or taking a testing point. So you get true statement is because below. Suppose I take another stupid testing point here, for example, 3, minus 3. Okay, the answer is completely false. And you plug it in the original, 3 times 3 minus 2 times negative 3 is less than 6. This is 9. This is 6. This is 15. No? If 15 is less than 6, no, it's completely false. That means at this point do not belong to the solution. This is clear? Okay, one is easy. Yeah, the thing is complicated when you have 2, 3, 4, 5, because we have a system that contains several inequality, no? Just in case I want to support the word using Desmos, I want to explain, pay attention, the fantastic way that Desmos allows us to solve in the system of the inequality when you have several inequalities. But let's continue with the another scenario, example 2, example 2, example 2. Let's do a couple by hand. A couple, no, 3. 1, 2, 3, and after we move into Desmos to see more clear the idea. Example 2 is x squared plus y squared less than or equal 4. Do the graphic solution of this inequality, no? In this case, non-linear inequality. So now immediately I copy my related equation associated with this inequality. I replace by equal sign, no less than anymore. Okay, now I bring a new rectangular coordinate system. Let me try. Okay. Entonces you realize what curve it is. Tell me, guy, what is that? What curve represents this equation? Come on, Vinny. Edward, Rachel, Gladys, Jenny, Natalie, Joshua, Brianna, Faisal, Kylie, Camila, good for you. Camila, Chelsea, my darling, Andres, and Kyler. Ok, entonces, what? Ajá, Chelsea. What is the curve que representa x squared plus y squared equal 4? Okay, suppose que student in intermediate algebra very well know. No idea. Nobody know anything. A ver. Opinion. I don't see the chat. Ay, carajo, I don't. Okay. I don't put it on my laptop to see the chat. All right, show me again. Oh, activate. It's a circle. Edward say it's a circle. Edward say it's a circle. Cool. And this circle, Edward, what is the center and what is the radius? Because when you're talking about a circle, the two pieces of information that we need to do the sketch of this circle is the center and this is the radius, no? Come on, guys, there are a lot of students here in my classroom. I need participation. Is radius 2. Who said that? Jenny. Jenny say que the radius 2. Okay. Where come from 2, Jenny? Where come from 2? Because center is 0. 0 or 0,0. 0,0, H and K, 0,0. Okay? It's a half. No, Jenny. Okay, guys, the general equation. What happened to you? I have a heart attack with you. What happened? What happened to the students after the pandemic? Andrés García, 0,0. Okay. You know, we go back 10 years before the pandemic. The level of the students, sorry, professor. Look, compare this equation and this equation. Es obvio que H and K do not exist, and the reason is because it's 0,0. This is H, and this is K. And 2 come from for the square root 4, no half. It's a coincidence, but it's not correct. Okay. So now the center is in the center, in the origin, 0, 0, and the radius 2 in any direction, 2, 2, 2, and 2. Yeah, I suppose my circle look like that. I try to do my best. After I promise in Desmos, oh no, good. In Desmos I am doing very well. Okay, I do my best. This is the curve that represents the equation, equal. And what about the inequality? So the circle encloses one area in the inside and one area outside. And what do you believe is the solution? The area inside or the area outside? Inside, outside. 50-50% probability. Inside or outside? Nobody? Nobody know? Inside. How do you know, Vlad, it's inside? Because inside. I agree with Gladys. It's inside. But what is the reason? I need to understand reason. You can take testing point or no? What is the famous testing point? Formula de tiempo es 0, 0. I'm plugging in into the original equation. Edward, 0, 0 again, Edward. 0, 0, okay, okay. Entonces 0 square plus 0 square should be less than or equal 4. And 0 square plus 0 square is 0, obviously, less than or equal 4. And this statement is true or false? What do you think? It's true or false? 0 less than or equal 4. Look like trivia, the question, but no, it's not trivial. I get that. I need to think if it's true or false, this statement. No idea? A ver, es true, es obvio que es true, es obvio que es true. Remember, that symbol is equivalent to say less than or equal. When you have a logical statement connecting by or, to be true, we need only one statement true. Es obvio que less than no es false. That part is false, pero that part is true. Okay, and si es true at least one, that's true. It's completely different to and. Suppose we have less than or equal, and you have and. Oh no, and is to be true, we must true both. In this case, at least one is true, this is true. Okay, now suppose the imagination, common sense, is less than, it's obvious que es inside. Oh, but I forgot to explain something. I forgot to explain. See, the curve is dotted line or solid line. What do you think? Is solid or dotted? Okay, that's solid. And the reason it's solid because our original problem is less than or equal. That means the equation, que es the part, this is the curve, the circle, is inside the solution. It belongs to the solution. Is it clear? It's easy. It's elementary. It's no big deal. Okay, suppose I change a little bit this problem. I put example, clear. Suppose example 3. Example 3 is the same example, but I change intentionally to confuse you. Greater than 4. Wow. 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 It's different or no? What is the solution? It's the same or different? Dotted line, he said, okay. So the related equation is the same. The related equation is the same. It's a circle, but now this circle is dotted line. Pam, 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 pam. Pam, 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 pam. Pam, 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 pam. Pam, 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 pam. Something like that. And what part I shape? I shape inside or outside? The challenge is inside or outside. So this curve, que es a circle, separate the plane into region. The region inside and the region outside. Now you have two possibilities, only 50-50, inside or outside. There are no another option. It's not like a line. Line is above or below In this case, the circle is inside or outside. What do you think? Is inside or is outside? One more time, you apply the testing point, no? But the testing point is the same, 0,0, no? I'm plugging in this inequality. It's obvious que 0 is greater than 4, que totally false. That means que the point below, que 0, 0, no, it's false, it's outside. It's outside, it's something like that. Boom, boom, boom. It's the part totally outside the circle. Infinity point, of course. In any scenario, infinity. They are infinity solution. Uy. Do you follow me? Do you understand very well or no? Very well or no? Comedian. Let's move into decimal to see more clear. I don't like this way. Not good. Let me try in decimal. Oh no. Okay. Now decimals. There you go. Okay. Do you see decimals? Yes or no? Do you see or no?
Yes.
Yes. Look, let's do it number 1, number 2, and number 3 example. Number 1, do you remember? It's a line. 2x minus 2y less than 6. There you go. Look at that. Do you see? Dotted line. The only thing that you should do is put the equation, put the inequality, sorry. And Desmond understand very well is dotted line and above the line is the solution. Cool? Yes or no? The example number 2 is similar. It's x squared plus y. It's a circle. And is, when you be here, wow, look at that. It's a circle. Is the region inside the circle. And example number 3 is a similar. It's also circle, but it's greater than, to says outside the circle, and the boundary is dotted line. Cool? Do you understand very well or no? Cool. Okay, so let's move on to 2 examples now, 4 and 5. Okay, we try to do by hand. We try to do by hand in the whiteboard, and after we come back here to Desmos to see the solution. Yeah, I want to explain the fantastic way to do in Desmos. Okay, let me see. Whiteboard. Do you see my whiteboard? Yes or no? Okay. Example 4. Example 4. What is the new complication that brings me the problem? It's that we have no one inequality, we have several. In this case, I don't want to complicate too much. You have two. This is the inequality number 1. So when you have a system, guys, it's important that you put the name of the equation. Equation 1, equation 2, equation 3, equation 4. Inequality 1, inequality 2, inequality 3. And 3x minus y less than or equal to 3. Inequality 2, and now it's the system. Now it's obvious when you write like that and no specification anything. I suppose that actually we need to solve one thing is like a y less than or equal 1/2. x plus 2, and this conjunction is not specification, but default you need to know it's like that. 3x minus y less than or equal to 3. It's the same idea of the equation. And the equation, when you have two equations, you need to satisfy one equation and another equation. And the intersection, because and is intersection, we need to find one region corresponding with the equation 1, and you need to find another region get the region with the inequality number 2, and the solution is the intersection, so the common part, because and indicate common part. Clear? Okay. Entonces now to manipulate, I recommend you always express it in explicit form. Explicit means que you isolate the y. Y isolated. Well, the first inequality is already cool. It's already. The second no. The second you need to express it implicit. Entonces copy 3x minus y less than or equal to 3 minus y less than or equal minus 3x plus 3 divided by negative 1 both sides. Entonces y is greater than or equal. You need to switch in, reverse it, flip it, because you are divided by negative. Not always happen, but in this case happen. The 3x minus 3. 3x minus 3. Okay, actually, entonces my inequality both expressed in explicit is y less than or equal 1/2 x plus 2 inequality number 1, and y greater than or equal 3x minus 3. Okay, it's equivalent 100%. This system have the same solution, but this is more clear in my opinion because it's expressed in explicit. Okay, let me bring the rectangular coordinate system one more time. Here I do both graphic. Okay, let's do the graph of the first. It's super easy because I can see the y in a set of this line, because actually it's a line, no? Is in 2 here, 2,0. 0,2, sorry. And the slope is 1/2. And you need to remember the slope is the ratio between two quantities, rise and run. If the slope is 1/2, it's because run is 2 and rise is 1. And rise vertical in that direction, rise. And run is horizontal in that direction, maybe run, or in that direction, doesn't matter, because it's to the right always, and rise over, so it's over 2 units, 1 unit, so it's 2 here. You get the second point. Okay, by the way, this point is 2,3, no? Makes sense? 2 points is enough to do the graph of the line. But I am confusing what kind of line I doing. I drawing solid or I drawing dotted? What do you think? Solid, because it's equal. Entonces solid, okay, no problem. It's solid. Okay, I did the first one. Oh no, I don't finish because I need to shave this. Okay, I don't know if it's below the line or above the line. What do you think? Below or above? Remember, the line split is the plane into semi-plane. We have 50-50%, below or above. What is the glue indicate us is below or above? And this is below. Why below? Because it's less than. I repeat again, guys. Less than, below. It's below and solid line. Okay, cool. Let's do it. So now I shade that part. This semi-plane is the solution of the first inequality. Okay, I am using the red color. Let's move into the solution for the second. The solution for the second, I can see in the inequality that is located the y-intercept at -3 here. 0, -3 because b is -3 and the slope is 3. There's 3 up and 1 to the right. I get this 3 rise, upward, and 1. Okay, now we connecting this point by the line. By the line. Let me use the rule. What kind of line are you using in this case? Solid line or dotted line? Solid again. Okay, I agree. Because they contain equal sign. Okay, let's do it. This is solid line. Okay. Now, what part is shape? Let me change the color. Let me change the color to green. To green color, I want to is green color. Is above the line or below this new line? Is below, above? Is above, yes. And above this line is the part. So we're solving separately two inequalities. The only detail you keep in mind is when the line is solid, the line is dotted, or let's just shape below or above the line. Now this is the most important moment. What is the solution? The solution is the intersection, the common point between the green region and the red region. Well, I believe you forgive me if I make a mistake and you correct me, because that is that part. Okay, let me use another hard black color maybe. It's that part. You see or not? Yes, it's that part. Okay. You agree with me? Cool. And it's the answer, guys. This is the answer. Okay. Let me take advantage of that moment to explain what is the way that we are doing in decimal. It's fantastic. It's fantastic. Pay attention. It's switching to decimals. Okay. Do you see decimals? Do you see? Yes or no? Okay, cool. This is example 4. It's example 4. But I want to explain it. Look. Okay, yes. I copy, but I copy in the special form. Look. You copy the first. Let me select this. I press in my keyboard in my keyboard, I press second X. No, coño. Okay. Control X. Guess it could. Okay, so I eliminate this only. This is only one inequality. Boom. Okay, remember that this was the inequality that you select in green color. No, what's green? Green color. Now let me try to open a new line. I copy Control B like a paste. Of course, I eliminate the curly bracket because I want to plot separately this new inequality. Bang is red. No, was red. And you see clear like a water. Okay, the intersection is this corner, no, this piece of the region, and we you see is red, but a little bit bold. The color of the red. It's nice, no? But this is no. I don't like this way. I don't like this way. The fantastic way is you put together the inequality. Let me put Control B. Okay, I delete this. Of course, I put the color that you want. Okay, remember it was the black color, no? Bang! And you see what is the interpretation in decimals. You put several inequalities separated by curly bracket, and decimal understand okay, is the AND operation and find the intersecting directly. And no necessarily plot separately and see using the eyes what is the common part. No, Desmos find the common part. Cool? Do you see? And this is the way that we are using so far from now. Because I promised I want to complicate a little bit your life. So no trivial example. No. It's hard. For me, always is hard. Okay. One more example, number 5. Easy. No big deal. But in this case, non-linear. Non-linear. Let me try to come back to the whiteboard. Okay, whiteboard. Do you see my whiteboard? Yes or no? Yes or no? Answer me, guys. Yes or no? Yes, sir. Okay. Suppose this. Okay, there you go. Suppose the system formed by 3 inequality. Wow. Y less than or equal minus x squared plus 4. Inequality number 1. Another inequality is x minus y greater than or equal minus 2. Inequality number 2. Yeah, he said yes. And y greater than minus 5. Okay, let me try to do my best by hand. This is the last time. Okay, solving the system of inequality by hand. After we using decimals anytime. Look. Image again. Okay, there you go. Boom. Okay, this is the rectangular coordinate system. This is my system of inequality. I have 2. Okay. Remember, important, is express any inequality in explicit. Okay, the first one is explicit because y is isolated. Cool. But I write immediately the related equation because I am familiar, no? For the equation more than inequality. Entonces, what is this equation? Okay, I suppose that you know very well. What kind of equation? What kind of function? Sorry. What kind of function is minus x squared plus 4? You know very well. We studied in detail that function in this chapter, by the way. Or using transformation, you can understand this. Huh? What kind? Is it a circle? Is it a line? No. No. What is that? Come on, help me. Wow. Nobody know? Exactly. It's like but but what the name of this is like downward. Parábola. Ya dice parábola. Ese parábola, quadratic function es parábola. You know very well. Hello. Okay. Okay. Parábola. Okay. And what about the way it is said? Ese parábola que open down, ¿no? Jenny say que ese parábola que open down. How do you know que open down? Because it's negative, ¿no? A is negative 1, quadratic function. And the y-intercept is when you evaluate 0, ¿no? Es obvio que 4. So the point is 0,4. It's 0,4 is here. We have parabola up and down. I suppose que look like that. Not exactly, but approximately using my common sense and imagination. Okay, because I know also que the x-intercept, que when the function is 0, you solve this quadratic equation. And this quadratic equation for sure give me minus x squared equal minus 4 divided by negative 1 become positive. Apply square root both sides, plus or minus 2. Therefore, plus or minus 2, so 2,0 and minus 2,0 is the x-intercept and the y-intercept. This is one possibility to understand, and using the transformation, you know, okay, this is the basic parabola x squared when you transform it by negative reflection. And when you add in 4, is moving vertical shift for unit up. Okay. And I don't know why I put the solid parabola. Is correct que es solid or no? I did well. Wow, coincidence. It's solid because and the inequality contain equal sign. And what part I shape? I shape inside the parabola. What part I shape? I shape inside the parabola or outside the parabola. What do you think? No idea. Remember the famous testing point? Testing point universal, everyone using 0,0. I'm plugging in 0 and y less than or equal minus 0 squared plus 4. 0 less than 0 is 0, and this statement is true. And 0,0 lie here. Therefore, the solution of this only inequality is that piece, that region inside the parabola. Inside the parabola. Okay. I did the parabola. Everyone understand the parabola? This is my first. Let's move on to the second inequality. It's too long, not hard, but it's long. And this is the most complicated thing in mathematics. In mathematics, the problem is when the problem is too long, if you make a stupid one mistake, you screw up everything. And it's wrong the answer. Let me try to do my best. The second inequality is x minus y greater than or equal to minus 2. This is no explicit as implicit when the y is not isolated. So I need to isolate the y. Minus y alone greater than minus x minus 2, no? Wow, too many negative. But by negative one whole thing, y alone is equal less than or equal, switching the sign, x minus 2, plus 2, sorry, because negative divided by negative plus. Oh, it's easy to do that because the equation related is this. I see que b is 2 positive here, and its lowest one, so 1 up, 1 to the right, and we have the line 45 degree, 45 degree, 45 degree. There you go in that direction. Let me using green color. Green color. Green color. Okay, I did that. I did solid. Makes sense, right? Solid. Because it's equal. Okay. Now what part I shape? I shape below the line or above the line? I shape below the line. Remember, the line is easy because the line split the plane into semi-plane. So we have only two possibilities, no? Above or below. It's above or below. How do you know that? Below, because that symbol is less than. So you shade that part. Bam, 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 bam. That part. Below. Below. Okay, now the last. Let me use one fantastic color, maybe blue for the last one. Oh, the last one is super easy because it's only y alone, no x, greater than negative 5. The equation is negative 5. I replace the symbol greater than or equal or less than or by equal to find the related line, and this is a horizontal line passing through 5. So say something like that, 0 degree, horizontal, flat, 0 degree, passing through negative 5, and negative 5 is here, negative 5. Let me use in blue color. Blue color. Es solid, no, es dotted, no? Es dotted, look, no equal. Es dotted. What part I shade? I shade below or above the line? Above. Because it's that part. Oh, no. Using the marker. Better. Is it that part? Okay, that part. So now, you know, it's horrible. And this is only 3 inequalities. Suppose you have 7, 8 inequalities. And one application problem que we see after that. And then it's too hard only when you are doing one by one. However, what is the common part? What is the I don't understand very well. Well, let me redo at the beginning. It's inside the parabola, que es the red part. Is below the line, and this is above the horizontal line. Entonces, en my opinion, you let me know si I'm wrong or right, is that part. Yeah. And this word can look like complicated. We are doing too fast in Desmos. So you write the equation, the inequality, sorry. In Desmos, you write y less than minus x squared plus 4 curly bracket x minus y. Not necessarily isolate the y. Not necessarily. You copy the original, negative 2, and another curly bracket y greater than negative 5. And Desmos, bam, doing that part directly without complication. No, no. Entonces we go to the more higher level of the problem in which solving the inequality is nothing for us using this tool, no? Let me try to show you. Desmos. Share. Desmos. Boom. Do you see Desmos? Yes or no? Okay. Okay. I don't know why I copied two inequalities, but it's okay. Let me try to fix it. Any problem? I did something, no? Entonces, okay, look, the parabola alone. Okay. And also, let me try to, this is the parabola, this is a line, this is a piece of parabola, but I need to bond it, and let me open the other, maybe, I don't know why, doesn't work, maybe, is y greater than or equal to, let me see, I lost, greater than negative 5. Cool. I don't know why I don't put like that. E is no trivial. See, this part is dotted line or no, but using your imagination, because you know mathematics, of course, it's obvious que yes, it's dotted line. So this is not perfect. This is one frame, a little bit help me to understand, but you, of course, always, I recommend que you using your common sense, coño, right? And of course, analyze the answer gets given by the software and fix it, because this is doing by human being and the software, no? And maybe there are some mistakes. Or no mistakes, some detail. So far, everyone follow me? So I put now 1, 2, 3, 4, 5, and that's it, too much. 5 examples of the nonlinear can look like horrible, but we are solving in 5 seconds using Desmos. And I would like you practice not now, because it's too complicated. Entonces, one student doing well, another student no. I have no time to explain in detail for everyone. So now, when you're watching, my recommendation is, when you're watching the video, you open your Desmos and practice, okay? Okay, so I have four systems now. Look, do you see my webboard now or no? Okay. Now complicated. Do you see what my webboard or no? Complicated. Example 1. Example 2. Here. Example 3. Yeah, Rachel. Example 4. Okay, the first example is no big deal. I suppose 3x minus 6y less than or equal 12, inequality 1, 2x minus y greater than 4, inequality 2. This is no big deal. This is similar. But I want to copy everything. You copy your notebook now. Here I want to solve it, of course. You open Desmos. I want to type in one by one. Okay, suppose example 2 look like horrible. Look at that. 3x plus y less than or equal 6. Number 1 inequality. 2x minus y less than or equal negative 1. Number 2 inequality. X greater than negative 2. Number 3 inequality. And y less than 4. Number 4 inequality. This system of inequality is different to the system of equation. Normally in the system of equation you have 3 equations, 3 unknown. Cool. 2 equations, 2 unknown. So it's the same equation amount. Okay, not always we study in detail after, in detail. But in this case, more free. We have more freedom. Not necessarily the amount of inequality is equal to the amount. No, because it's a region. So inequality number 1 represents one region. Bam, 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 bam. Inequality number 2 represents another region. Bam, 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 bam. And the connection in between is the intersection. But we have 3 inequality and 4 inequality. You know what is the solution? The solution is the common point in between 1, 2, 3, and 4. Okay? Suppose number 3. Number 3 look like horrible also. 2x plus y less than or equal 6. Inequality number 1. X plus y greater than 2. Inequality number 2. X less than or equal 1, less than or equal 2. What the hell? This is a compound inequality. It's 3 pieces inequality and 1 inequality. Actually, we have inequality 1, inequality 2, and this 3 is 3a and 3b. 2 inequality together. Okay, this is classical. 3a and 3a and 3b. Of course, not necessarily split like that. And y less than 3, inequality number 4. And this is my system. I need to find the common part in between this inequality. One more, the last one. X squared plus y squared less than or equal 16. Inequality non-linear. This is linear. Example 1 linear, example 2 linear, example 3 linear, because it's lines. Exponent 1. When exponent is 2, exponent is greater than 1, it's non-linear, or square root another function. And this is x plus y greater than 2. This is no big deal. It's 2 inequality, 1 non-linear, 1 linear. By the way, it's a circle. Let's do it one more. One more. Example 5. It's very interesting. Example 5. Okay, is parenthesis x minus 1 squared plus y plus 1 squared less than 25. And x minus 1 squared plus y plus 1. Oh, what the hell? It's the same, no? It's greater than or equal to 26. This is very, very interesting. That is the reason I need to include number 5. Because number 5, you will be able to identification this inequality guy. Well, okay. The related equation. Look. Let me start for the last one. Oh, no. Only identification. It's x minus 1 squared plus y plus 1 squared equal one number, no? 25 or 16, 16, not 26. Sorry, es 16. O sea, ese nombre que es perfect square, no? Because the square root 25 is 5 and the square root 16 is 4. This is a circle, yes or no? Your R square is a circle. It's a circle, 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 circle. Ay, 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 spelling, coño. Circle, 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 where the radio is in the first scenario 5, in the second 4. But the center of this circle is common, is at the point 1, -1. Remember, this is H and K. Entonces, básica is a circle where the center is that famous point and the radius 5 and the first inequality in the second 4. Same center. Entonces, and then is, wow, look like a ring, no? Because it's inside the big circle and outside. Entonces, when you highlight, I suppose que está part. Make sense? It's curiosity. Make sense? Do you see now in this one? Let me know when you finish to copy that. Done? Okay. Let's move to Desmos. Yeah, system of inequality is the name of this. Sample 2, sample 1. Okay. Let me try to share Desmos screen. I suppose everyone have in your paper, in your notebook, the system. Okay. Okay, there you go. Boom, boom. Okay, look. Do you see this one? Look at my first example. Is 3x minus 6y less than or equal to 12 and 2x minus 4 greater than 4. Wow. Unplug that. By curiosity, I determine this point, okay, this point is too easy to determine because you are doing the intersection. So you consider like equation. You replace in your paper equal sign. So you find two related equations and you solve the system, and the system is 4/3, comma negative 4/3. Okay, to find that point is too easy. You suppose the boundary is the line, you intersecting is a simple system of two equations and two unknown, and you solve it. I don't want to waste the time with this. What's important for me now is, can you understand how you write the system of inequality in Desmos? Okay, and you avoid the long, stupid procedure. Okay, you are doing one graph, separate another graph, and finally intersecting. And this is relatively easy by hand, but the next, no. The next is crazy. Look, example 2 is, wow, how many? We have 1, 2, 3, 4. 1, 2, 3, 4 inequality. You separate by curly bracket. Desmos understand very, very well que is and between the inequality, and when you are doing the graph, you obtain, okay, let me make it zoom to see more clear. You obtain, this is a typical format, guys, of the application of this. I want to explain in a few minutes. Is a system of the inequality, not always, but frequently formed a closed surface. In this case, like a polygon, no? In this case, you have 1, 2, 3, 4. It's a quadrilateral, no? 1, 2, 3, 4. But look like two triangles together. I don't know. ese polígono, pero this is characteristic, typical characteristic of the linear system of inequality. The solution frequently is a polygon. And how you find the corner of this polygon? Easy, because you put by a couple pair two equations and solve the set. Take another couple, solve the set. Take another couple, solve the set. We have 4 solutions, and each couple have a common point, the corner. Makes sense? Do you follow me? Cool, Jenny. Okay, this is curiosity. I want to explain the procedure, general procedure. You have to practice, guys. You have to practice. And the homework is waiting in this chapter. It's a little bit hard. So I encourage you, any student can have mistake, send me the screenshot of the question that you don't understand. I try to explain. Okay, Chelsea. Okay, one more example. One more? No, we have 5, no? 1, 2, 3, 4, 5. This is the second. Now the third is this. 2x plus y less than this guy. Boom! Look at that! Look at that! The solution of this linear system of inequality is this. Okay. I copy the first. I copy the second. I copy the third. I copy the last. And it's extremely important, extremely important. Can you find the corner? I want to explain why after, no. So the corner is 1, 1, 1, 3, 1, 5, 3, 2, 2, and 2, 0. The corner is extremely important. This is the solution. You copy in decimal 1, 2, 3, 4 inequality, and that's it. Everyone follow me? Okay. Let's do it now. Let's do it. You know, there are some students who understand much better some topic. This is the, it's a learning process. Some students understand very well when it's visual, when it's graphic. Another student say, no, I don't like the graph. The graph is horrible. Suppose number 4 is non-linear. Non-linear. It's a circle, but it's inside the circle. Look. It's inside the circle. And above the line. This is the line. Get cross and 2 point, bam. This is now. This is the to find this point. Well, the only thing you should do is copy like equation and solving the non-linear system of equations, similar to the idea that we are doing in the last class. Okay, but it's clear, no? It's inside the circle and above the line. Okay. And number 5 is the famous ring. Okay, try to explain. Look, okay, it's 2 circles. Bang! Look at that. By the way, the center of this circle is located at the point. Let me see, at the point 1, -1. Let me check it out. This is the point, 1, -1, both. Bang. And the label is 1, -1. Beautiful. It's beautiful or no? Any question? Do you understand this or no? Sure? Okay. So we come back to our whiteboard. Do you see my whiteboard? Do you see? cool. Well, I am practice a little bit switching to the whiteboard. That's most, well, for me this is hard. Okay, now we study a new thing, que es the application of this. You say, well, professor, I understand, but what is the application? Well, the application is relatively new branch in mathematics. It's called linear programming. Linear programming. Period. Done. Linear programming. Entonces, linear, you know, que son en matemática de cuando the thing is linear, es because it's line, it's flat, it's maybe line or maybe plane. Depende of the dimension, no? 2 dimension or 3 dimension. And programming sound like a computer, no? But actually it's not computer. Typical problem of the linear programmer is like optimization. I want to optimize something. Optimize means find the best option in one situation. And for example, see, we have a problem talking about profit of the business. I would like to analyze the maximum profit because profit is money. Money is good when it's coming to my pocket. However, see, you're talking about cost. Cost is money, but it's bad money because I need to spend this money in one business. Therefore, I need to minimize the cost. This process is called optimization. And the typical format of the optimization problem is we have 2 pieces of information. The first piece, que is the most important, is the objective function. Objective function. Always any problem of the optimization have 2 pieces. The objective function and the constraints. Constraints. The constraint is related with the possibility that we have in this problem. Suppose that we have available some hour to work only. I want maybe to work in the week 60 hours, but no. The law in the United States says 40, okay, 40, because I need to work. I need to find another part-time maybe, okay. But this is the restrictions, okay, you need to obey, it's the constraint. But the objective function is the most important because in the first example that we're doing now, okay, I don't want to talking about anything, it's only mathematics. After I explain word problem using things, using money, using coffee, using tree, using something, object. Now, in this case, we have the objective function. I don't know why always is called Z. Capital Z is equal to 50 X plus 150Y. It's a given guy, this formula. Yes, the formula that you need to optimize. How you optimize? Well, there are 2 possibilities, or maximize or minimize. In this case, it's maximum. So, and the problem you can see in the test, it's a linear programming problems. It's giving one objective function and a specification in what direction you need to optimize. It's maximize or minimize. Okay, and it's giving also some constraints que bounded my problem. Let me try. X plus y less than or equal 60. Suppose hypothetically, no? Hypothetically, suppose que X is the hour in one full time que I have, and where Y is the hour in the part time, so I need to work 60 hours. Yeah, that's it. Because I am human, I don't want, or I cannot work more than 60 hours. And also another constraint is Y greater than or equal to X. Okay, there's 1, yes 2. And this is the constraint. And the constraints form a system of inequality in 2 dimensions, linear. Okay. And the first thing you should do is you solving the inequality system. Let me try. But not here. Let's do it in decimal. I want to do roughly. Suppose like that. You are doing the graph of this. Suppose it's a line like that. This is the x in a set. This is the y in a set. I promise that we are doing formally in decimals. Yes, the way I want you are doing. And this is a 60, 0,60, and it's a 60,0, no? Because x plus y is 60. And we have another line passing through the origin. Is the line y equal to x. And this is the line x plus y equal 60, no? And this part is inside, so below, because less than, and this is above. Therefore, my solution is like that. This is the solution of the system. You ignore the objective function so far. And this give me one thing is called a feasible region. Feasible, que es the region que es available, que have sense my word problem. Now I'm going to optimize or minimize. You evaluate the objective function, because the objective function actually is another line. That is the reason of linear programming. Everything is linear here. It's linear the constraints, it's linear the objective function. And I suppose hypothetically that my objective function is another line like that. C equal 250x plus 150y. And when you moving x and y, this line moving in that direction, in this direction, I move in parallel. And in one moment, touch. I suppose it's here, touch. The feasible region. Of course, we have solution here. When you go inside, you have solution. But the optimum solution is obtaining in the corner. That is important, the corner. So one corner here is 0,0. Another corner here is 20,40. What comes from that? Well, the solution of this system. Let's do it quickly to understand. Suppose x plus y equals 60. Y is equal to x. Oh, I apply substitution for solving the system. Equation 1, equation 2. And y is isolate. Good, I apply that. So I substitution here. Substitution who? Substitution instead of y to x. That's it. X plus 2x is equals 60. 3x is equals 60. Therefore, x is equals 60 divided by 3 is 20. And in order to find the y value, you using the easy example, easy equation, sorry, get the equation 2, can duplicate that, that's a 40. And the famous point is the point 2,40. So I have, okay. Recap again. We have the constraints, okay, in this case 2 inequality. But suppose you have 4 inequality, 5 inequality. You are doing the graph in decimals, and you obtain the feasible region. Feasible region is the region in which our problem makes sense. Because outside the feasible region have no make sense. Okay, feasible. Let me copy here. Feasible region. Feasible region is the red color, get the solution for the inequality. But the important information for me is the corner of the feasible region, because it's the optimum. How do you know it's the optimum? Because when the objective function, it contains 2 variables, travel for the plane and touch the feasible region, gets the condition available in our problem. The maximum or the minimum is obtaining in the corner, right? Because here I have a lot of points, it's satisfied both, but it's no maximum or minimum. So what should I do? Well, you determine the corner. The corner was, let me try to erase something I don't need. I don't need this, I don't need this, I don't need this. No, and no. Okay, remember I have a line here. Okay, and I don't care too much the equation of this line. Okay, now I have the important information now is corner 0, 0, 20, 40, and 0, 60. And you plug in these three, there's a triangle, it's a square, it's a four corner, and the objective function. And 0, 0, the x0, y0, it's obvious it's 0 because 25 times 0 plus 150 times 0. And it's completely useless. Bueno, no, si es mínimo, yes. Evaluate now in 0, 60. It's 250 times 0 because x is 0 plus 150 times 60. I put in the calculator. 150 times 60. 150 times 60 is 900. Suppose que es the profit, $900. And let me evaluate the other que es 2040. Entonces 250 multiplication by 20 plus 150 multiplication by 40, no? So 250 multiplication by 20 is 500 plus 150 multiplication by 40 is 6,000. Entonces 11,000. Okay, so I discovered, wow, fantastic. The maximum occurred in that point. So what's the answer, Professor? The answer is, we have a maximum. Que es igual 11,000. I don't know si es dólar, es dólar. You put its dollar sign. Y this maximum occur at the point 20,40. Okay, in conclusion, x is 20 and y 40. Okay, suppose we have normally the basic idea of that problem is that we have to think. We have to coffee, to tree, to something you want to sell. You are a manufacturer or something, and you need to optimize the profit or whatever. Okay, let me show you this idea. Do you understand the idea or no? Or it's confusing? Linear programming. Now it's a new situation. We have linear system of inequality. And normally in this language of the linear programming is called constraints. And this determined in the plane, because it's two variables, just three variables is more complicated, is determine the feasible region. Now you need to evaluate the objective function, que es the function that you want to optimize in any corner, bam, 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 and you get the maximum value you want maximize, or you want to find the minimum values you want to minimize. Okay, cool. Let's see the same job, how we are doing easy and decimals. Okay, let me try to find the script of the linear programming, linear programming. Okay, this is sample one. Oh yes. Okay. Let me share the screen. Okay. Linear programming is another screen. Desmos. Do you see the new Desmos? Linear programming. Look. Oh, it's different, professor. Well, no. Do you see a yes or no? Let me know. Hmm? Oh, I see. Okay. Look, guys. We have the constraints as this. I forgot another constraint. Actually, I copied only two, but I copy also two new constraints, Camila, que es x greater than or equal to 0 and y greater than or equal to 0. That means it's the first quadrant. And the solution of my problem lie in the first quadrant because maybe it's a money, and the money, well, possible to be negative, but no negative. So now, boom, I do the graph of the feasible region, very similar to the thing I did in the whiteboard. Okay, I copy by curiosity. You don't care too much for this. The line can represent the objective function. Look, this is the objective function. But the important is, in this table I create here, I copy the corner, 2040, 060, and 00. And you can see that the maximum is in 11, and this happens at the combination 2040, x equal 20, y 40. I try to visualize using this slider. When you move this line, this line blue represent the objective function. It's also line, it's linear. But you see amazing, okay, the first point in which the line touch, ping, approximately, touch the polygon is here, it's exactly in 11,000. Let me try 11,000. 1, 2, 3. Bam. ¿Qué es el máximo? Vale. Do you see now? Do you understand the idea? It's fantastic, right? That part of the mathematics was created in the Second World War because the army in the United States need to optimize the war. Of course, the technique is used now to simulate the war. Of course, in multi-dimension. I explained one elementary problem in 2 dimensions. That is the reason that we can represent in the rectangular coordinate system xy. And one real problem that we have multi-dimension because you need to analyze the transport in the army and in the war, the food, every situation, the amount of those soldiers. Of course, you need to include several multiple variables, and the representation graphical is impossible. But the representation is using algebraic expression, using the matrix, que is the next topic we are studying in this chapter. Okay, the matrix allows us represent one situation in multi-dimension. Okay, one more example of the linear programming, and I want to finish doing maybe a couple of the word problem to see much better because I don't know si we are talking about money or no clear to send the word problem. One more example, only using pure mathematical, no necessary interpretation word problem. Example 2, let's do it. Let's do example 2. In example 2, we have the linear programming problem que contain 4 inequality. For inequality, boom, for inequality, let me make it zoom, The solution of this inequality automatically decimal is doing directly. And the corner is 0,4, 0,8, and 4,0. Okay, the objective function, you can move in using this slider. You can see that, okay, the first point you touch is 0,8, boom. And in 0,8, the value of the sig, the objective function, is 16. Look at that. Here's the maximum, and the other corner is 12, and the other corner is 8. Here's the maximum. Do you get the idea? Confusing or clear? A little bit, no? You have to practice. I promise. I promise. Okay, in the test, don't frustrate. See, in the test, I never put the word problem because the word problem bring me complication. Because for suppose you, when you read the problem, you don't understand very well, so we cannot solve it, and you lost this question. No, in the test, you see a couple of problems. I don't know, see 2 of the linear programming, but no specifications, si es money, si es, no, es just mathematical. You apply the restriction, the constraints, you find the feasible region in decimals, you find the corner, and you evaluate the corner and the objective function and determines si es mínimo o es máximo. Okay? Okay. Let's move on to example. At least 2. To understand much better this. Do you see my whiteboard? Yes or no?
Yes,
okay.
Yes.
Let me try to bring the image of the first word problem. Is here over there. Okay, this is that. Boom. Okay, problem number 1. Wow. Let me read. This is the complication. You read to understand. It's about the nursery. Nursery. This is a plant nursery cell two sides of 3. Always there are two features. Now, see, we have 3 features to say the problem is in 3 dimensions, and the optimization is more. But in this case, only in the plane, using decimal to have 2. So this is a plant nursery cell 2 sides of 3. Oh, 2 line scheme. The monthly demand is at most 310, 310. Furthermore, the nursery does not want to allocate more than $29,700 each month on the inventory tree. So for the capacity of this nursery, there is only this. So this is a restriction, this is a constraint. Determine the number of the large tree and small tree that the nursery should have in its inventory each month to maximize the profit. Wow, too much. Okay, does I want to call, maybe, using the same variable we use frequently every day. X is large, 3. Now Y is small. Because I need to set out everything. Remember, the problem in the linear programming contains 2 pieces. The piece of the objective function and the piece of the of the piece of. Okay, so now objective function. Okay, if we focus in this column of this table, profit. Okay, obviously is the thing I need to maximize, no, the profit. So now the C function, que the objective function is equal 55x, little by little you form the algebra, and 29y. Make sense? They multiply, so you earn $29 per each small tree, and 55 per each large. And this is the objective function that gives the function connecting the money with the amount of tree you sell. Make sense in this equation? I need to maximize. This is the key word in that problem, max. However, we have limitation, we have constraints. And the constraint, let me read again the problem because I don't understand anything, Professor. We have two kinds of tree, but the demand is 350. So x plus y is amount of large plus amount of small together. Monthly demand is at most. And what is at most, Professor? At most, when you hear mathematics at most, this is less than or equal. So you see at least is greater than or equal. Okay? This makes sense or not? Also, the bigger amount of the tree, this is science fiction, no problem. It's no, actually, is 310. And this is my first constraint in the problem. Okay, one more constraint. Well, they have limitation with the money in this business. Furthermore, the nurse does want to allocate more than, okay, more than 20, more than 20. But this is the limit of money. Okay, it's available in this company, no? So now the cost column, que the money that the company need to spend in the business, is $7 for each small and 110 multiplication by x, que represent the large, plus 70 multiplication by y, que represent the amount of small, and this is less than, no equal, $29,700. And this is the constraint number 2. Do you understand the idea behind this? Complicated. Come on, opinion. Don't accept anything. You thinking, processing, and ask me any question. The problem talking about one company gets a nursery, sell trees. We have two kinds, large and small. I don't know if it's better in the business, sell small, is better or not, or large. This is the challenge to discover that. Now, the profit column in the table give me the information, the money get inside the company. It's the positive money. However, in the second column, que es the cost, is the negative money. It's the money I need to invest to start the business. Or no start, maintain the business. Entonces es obvio que taking the profit, que es the quantity I want to maximize, es 55x plus 29y equals z, que z is the letter that we use frequently in linear programming to call the objective function. That part is okay? That part is okay? No? Confusing? Okay, get it said. However, we have constraints. That's all we happen in the real life. we have the total amount, the maximum at most 3 that we can store inside the capacity of our business is 310. Okay, I respect. 310 include both. Include small and include large. So x plus y less than or equal to 310. This is my first contract. And the money I have in my account is $29,700. No more money I can pay. So now I multiply the cost for each kind of 3, multiplication by x and y can represent. What represent x and y? The number of large and the number of what? The number of 3. Okay, it's large, this is small. Okay, I don't know, said at the ending we have 5 large and 20 small. And this give me a maximum profit. Wow. Or no? Or no? Surprise. Surprise. This is the beauty of the linear program. Do you understand the equation and how I separate like constraints? Y I separate like okay, now what should I do? Take a piece of paper? No. I go to Desmos. I go to Desmos. Let me try to find, because I don't find the linear parameter word problems. Linear problems, okay. Problem number one. Okay, number one. Let me see if you see or no. Number one. Switching to linear parameter word problems. Desmos script. Do you see that? Okay. Problem number one. Look at that. I just copy, in the first line, I copy the constraints. This constraint is important, guys, to be positive, because the 3 never is negative. It's have no sense. So my solution lie in the first quadrant. Okay, you can copy like that. Look, let me show you. Bang. What the hell? Look at that. Look, I copy, for example. So now the classical question for the students is, professor. Where come from? This is the feasible region. Get the solution. Look at the red color. Oh, not exactly red, it's pink, I guess so. Bueno, okay. So how you find the corner? Well, the corner is easy. Look, you put it, for example, this equation, bang, and this equation, bang, and the intersection, you see, this is graphically, but algebraically you can intersecting the equation. So you convert the inequality and the constraint like equation, and you solve it, and you obtain the corner. Okay. I want to simulate, but not necessarily you need to do like me. Okay, when you approach it, bam, the first point que touch, is this point. Okay, is exactly, let me see. No, is this. Okay, let me type in directly, because using the slide is no accuracy, you know. 14,850. After I want to explain by hand, bang, and you see, after I want to show you in the board, guys, the computation of this, and you see the first point, the objective function, the green line touch the feasible region is at the point 270,0. 270,0. Okay, so what is the conclusion? I don't understand anything. This is the maximum. Okay, let's see I change, for example, this. Look, the money decreasing, no? This is the maximum here. The maximum here. Okay, I did graphically to illustrate you, but in the real life, no. You have the feasible, you have the corner, you evaluate one by one, 1, 2, 3, 4 vertex, 4 corner, and the objective function, and you get the maximum value. I want to do now. And suddenly happen que is located at the point 270, so the maximum is $14,850. It's a maximum profit at x equal 270 and y 0. So what is the conclusion? The conclusion is the best way, the optimal way to sell the tree is sell 270 small, not large, no? Large, because x is large, 3, and no small. So you sell small, maybe look at that here, the money is smaller, no good. You lost money. The optimal combination is this. Not always, but in this problem, guy, no, I bring one problem, no. You say no, don't say always is like that. No, depending, you need to find that. What should I do? What should I do? Do you see the geometric picture of the problem? Do you see? Now let's go. Let's move on to the whiteboard to compute more clear. More clear. Do you see yes or no? Yes or no? Okay. No. Let's go to the whiteboard. We discovered in the decimals. We discover. Let me try. Wait. Let me try to make screenshot, because this is important for me. Screenshot. Okay, screenshot. There you go. One screenshot of that part in decimals. I want to come back to whiteboard. Okay, let me try. Save in the same folder. Okay, this is decimals. Oh, okay, either way, screenshot. Okay, now I come back. Do you see whiteboard or not yet?
No.
Not yet. Okay. Now? Now?
Yes.
Okay, cool. Now I want to bring the screenshot I did in decimals, because I am confusing when I switch into another Okay, there you go. Look, I have my problem. I have the decimal work I did before. Fantastic. Now this is a crucial moment. Guys, don't hesitate when you are doing in the homework these problems. If you don't know, you send me, I try to solve for you. No, don't hesitate, because I know it's a little bit hard. So now basically this is my objective function, and this objective function I need to evaluate in this corner, and this corner, and this corner, and this corner. And the 0, 0 is obvious, que es 0 money, not good. And this corner, que es 0,310, que es under the supposition that you sell no large, 0 large, and 310 small. Remember, our maximum available to sell is 310. At least the problem say when you plug it in and your multiplication 55 times 0 is 0, 29 times 310 is 8,990. This is money, total. Another corner is 210. So you evaluate C, the objective function at 200. 110. Now multiplication is 14,190. Good, more money. Best is the best, but that's not the best. The best occur at the point 270, comma 0, is $14,850. This is the maximum. The maximum occur at that point. But the maximum is profit. C maximum is $14,850 at the point X equal to 70 is a large 3. I know small. No small. Small is bullshit. It's a mess doing this way. Do you understand the idea? Do you understand? Okay. Don't frustrate for this. I go over it again in the review package. No problema. In the test, never you see, if you want extra credit, let me know the student get 1 extra credit because I have the collection of the word problem of the linear programming and 1 PowerPoint. I send to you the student get once, or I send to everyone now after when I finish the video. I send with the video the PowerPoint, and you are doing no number 1 because number 1 I did, but we have 8 or 7, I don't remember, 8 problem, and you have 5 points for each problem. Okay, but it's complicated because number 1 you need to set up the equations, constraint and objective function. We go to decimals, represent the feasible region, determine the corner, and after evaluate the objective function in the corner, and you optimize your problem. Okay, do you want? You there? You see? You can know? Okay, no problem. And you send me back together attached with the test number 4, no? Reading test, the extra credit, to improve your grade. Entonces now, okay, no, Jenny, you don't need to prove, but the student need to improve, take advantage of this. You have to work. Okay, guys, too much for one day. I suppose it's enough. Okay. Stop sharing. You see my face? Yes? Okay. Bye-bye. See you Wednesday. Okay?